Welcome to the Engineering Update. I'm Casey Panetta, editor of ECN. In this week's video, Goodyear's electricity generating tire, kids learn to code, and a space camera repurposed for Earth.
We've all heard of regenerative braking, where kinetic energy from brakes is captured and returned to the vehicle's batteries. Most of the popular hybrid and pure electric vehicles like the Prius, Tesla Roadster, and Chevy Volt use some form of regenerative braking to cut down on energy consumption, be it less fossil fuels or just to save on electricity. But Goodyear wants to take this concept one step further by creating energy-generating tires. Their BH03 concept will work to capture kinetic energy in two ways. One way takes advantage of piezoelectricity, which builds up when objects are deformed, since tires are always being compressed, and this energy is usually lost. The other method would capture energy via thermoelectricity. As you may have noticed, tires generate quite a bit of heat, be it from spinning on the road or just sitting in the sun. Goodyear would use thermoelectric materials like bismuth telluride and tin selenide to generate electricity by contrasting the hottest and coolest parts of the rubber. Goodyear's BH03 concept is still probably 10 to 15 years from conception, and by then, hybrids and electric vehicles could be more pervasive in society. And the whole idea would collapse if engineers had to sacrifice durability or elasticity. Everybody loves saving energy and money, but nothing's worse than a flat tire.
The UK is currently facing a skills shortage with a projected need for 1.4 million digital professionals over the next 5 years. Because of this, a new BBC initiative has been launched. Their Make It Digital initiative is providing all Year 7 students across the UK with a microbit coding device, a whopping 1 million devices in total, in order to get kids inspired to get creative with coding, programming, and digital technology. The microbit will be a small wearable device with an LED display that children can program in a number of ways. It will be a standalone entry-level coding device that allows children to pick it up, plug it into a computer, and start creating immediately. The microbit can connect and communicate with these devices, including Raspberry Pi, as well as other microbits. The new initiative will also create up to 5,000 digital trainees, partner with around 50 organizations, and launch a season of dedicated BBC programs and online activity. The Make It Digital traineeship will create opportunities for up to 5,000 young unemployed people. They've partnered with major organizations including ARM, Barclays, Google, Microsoft, Samsung, and others. BBC Make It Digital hopes to get younger generations excited about digital creativity. It will attempt to use TV, radio, and online content to inspire digital people, and will focus on helping younger audiences discover their creative potential and take their first steps into the digital world.
When you think about it, space is just about the harshest environment there is, so anything tested on ISS or a satellite should be good on Earth. Recently, the European Space Agency, or ESA, announced that a digital infrared sensor they designed in partnership with the Belgian company Zenix is being adapted for use in medical and consumer industries. Currently, the high-speed camera is being used on ESA's PROBA-V satellite to take pictures of Earth's entire vegetational growth every 2 days. The satellite was launched in May of 2013 with the mission of mapping Earth's flora, as well as tracking aircraft signals from space. It has been used to monitor rainforest growth and offer information on crop yields. The camera is capable of capturing line-by-line information of pieces of land that are 1,400 miles wide. The agency believes that the characteristics that make the sensor so incredible at capturing data will be beneficial in less grandiose situations like fast-moving projection lines or recycling sensors. Projection lines are of particular interest because their movement is similar to the Earth's movement in that it requires quick line-by-line scanning in order to differentiate between objects that look similar at a glance. For example, the camera would be able to differentiate between different types of plastic for separation purposes. This also makes the sensor useful for spotting defects in solar plants, where it would be required to use the glow of cells to determine efficiency. In the medical field, the infrared sensor could be used to detect skin diseases, as it can assess tissue at a deeper level thanks to its wavelength sensitivity.
That's all for this week's video. Be sure to check in on Facebook and Twitter and view past episodes at ecnmag.com. For the ECN channel, I'm Jason Lundberg, and this has been your Engineering Update.
What is that dramatic pause?
Yeah. Thanks, yeah. Keep that in there. Cut!